Hello everyone and welcome to today's presentation. I'm excited to introduce our topic, force and law of motion, specifically for Class 9 CBSE. On this first slide, you'll see the title, Summary by ClassCloud. We'll be exploring the fundamental concepts that govern how objects move and interact. Over the next few slides, we'll cover key principles, laws, and real-world examples to help you understand these important topics. Let's get started. Now let's look at the summary by ClassCloud for Class 9 CBSE. On this slide, we focus on the chapter summary. First, we start with the introduction. Motion, as we know, can be either uniform or non-uniform. But what's important is that the cause of motion is force. A force is essentially a push, pull, or hit that causes a change in the state of motion or even the shape of objects. We don't see force directly. Instead, we observe its effects. For example, when we push a door or pull a drawer, we see how the object responds. Moving on, we connect this to the law of motion. The key idea here is that force is fundamental to understanding how objects move and interact. Throughout this chapter, we'll explore how forces work and their role in the laws of motion. So in essence, force is what makes things happen, whether it's starting, stopping, or changing direction, and understanding this is central to grasping the entire concept of motion. Today, let's talk about forces and how they affect motion. First, we have balanced forces. These are forces that are equal in size but act in opposite directions. When forces are balanced, they cancel each other out, which means there's no change in the object's motion. So, if you're pushing a box and the push is perfectly balanced by friction, the box just stays at rest or keeps moving at the same speed. Now, on the other hand, we have unbalanced forces. These are forces that are not equal, so one force is stronger than the other. This causes the object to move in the direction of the greater force. For example, if you push a box on a rough floor with a stronger push than the friction opposing it, the box will start to move in the direction of your push. Friction acts like a balancing force, but when your push surpasses it, the object accelerates. This all ties into the law of motion, which explains how and why objects move or stay, still depending on the forces acting on them. Understanding these forces helps us see how everyday objects behave and how motion is affected by different pushes and pulls. Let's talk about the first law of motion, also known as the law of inertia. Galileo was one of the first to observe that objects tend to keep doing what they're already doing, whether that's staying still or moving. This means that unless an external force acts on an object, it won't change its state of motion. Newton formalized this idea with his first law, stating that an object remains at rest or in uniform motion in a straight line unless compelled to change by an external force. Essentially, objects have a natural tendency to resist changes in their motion. We call this resistance inertia. To understand this better, think about everyday situations. When you're in a car that suddenly brakes, your body lurches forward because it wants to keep moving at the same speed. Or when a bus starts suddenly, you might fall backward because your body is resisting the change in motion. Similarly, during sharp turns, you feel pushed sideways. Your body wants to continue in its original direction. So the key idea here is that force is what causes objects to change their motion, and inertia is the reason objects resist that change. This concept helps us understand a lot of everyday phenomena and is fundamental to the laws of motion. Today, we're going to talk about inertia and mass, which are fundamental concepts in understanding motion. When we say that heavier or more massive objects have greater inertia, we mean that they resist changes in their state of motion more than lighter objects do. Think of it this way. If you have a heavier box and a lighter one, it's much harder to push the heavier box because its inertia is greater. Now, mass is actually a measure of this inertia. The more mass an object has, the more inertia it possesses. That's why heavier objects are harder to start moving or stop once they're moving. Let's consider some examples to make this clearer. Imagine trying to push an empty box versus a full one. It's definitely easier to push the empty box because it has less mass and less inertia. Similarly, when you kick a football, it moves easily across the ground, but a stone resists movement because it has more inertia. All of this ties into the force and the law of motion, which explains how forces cause changes in motion. The greater the inertia, the more force you need to change an object's motion. So, understanding inertia and mass helps us grasp why objects behave the way they do when forces are applied. Let's talk about the second law of motion and how it relates to force. The key idea here is that momentum, which we denote as p, is calculated by multiplying mass by velocity. Newton's second law tells us that the rate at which momentum changes is directly proportional to the force applied. In simpler terms, if you apply a greater force, the change in momentum happens faster. Mathematically, we express this as F equals ma, where F is force, m is mass, and a is acceleration. The SI unit for force is the Newton, abbreviated as N. Now let's connect this to everyday life. For example, when catching a cricket ball, if you pull your hands back to increase the time over which the ball is caught, you reduce the force on your hands. Similarly, in high jump, athletes often land on cushioned beds to absorb impact, which is a practical application of reducing force by increasing time and energy absorption. Understanding this law helps us see how force and motion are closely linked, and how we can use this knowledge to improve safety and performance in various activities. Now let's talk about Newton's third law of motion, which is a fundamental concept in understanding how forces work. It states that to every action, there is an equal and opposite reaction. This means whenever one object exerts a force on another, the second object exerts a force back on the first, equal in strength, but in the opposite direction. It's important to note that these forces act on different objects, not on the same one. For example, when you walk, your feet push the ground backward, and in response, the ground pushes you forward. This push and pull is what allows us to move. Another example is when a gun recoils after firing a bullet. The bullet shoots forward, and the gun moves backward with an equal force in the opposite direction. Similarly, if a sailor jumps forward off a boat, the sailor moves ahead, but the boat moves backward. These examples help us see how the law applies in various real-life situations. This law connects directly to the overall theme of forces and motion, because it explains why objects move the way they do when forces are involved. Understanding this helps us grasp the balance and interaction of forces in everyday activities and in the universe at large. Let's wrap up our discussion on the key takeaways from Class 9 CBSE Physics focusing on the laws of motion. First, we have Newton's first law, which states that objects resist change in their state of motion. This resistance is called inertia. So, if an object is at rest, it stays at rest, and if it's moving, it continues to move at the same speed and in the same direction unless acted upon by an external force. Next is Newton's second law, which tells us that force equals mass times acceleration. This means the heavier an object is, the more force you need to change its motion. It also connects to momentum, which is the product of mass and velocity, basically, how much motion an object has. Then we come to Newton's third law, action equals reaction. Whenever you push or pull on something, that object pushes or pulls back with an equal and opposite force. This is why, for example, when you jump off a boat, the boat moves backward. We also need to remember that friction always opposes motion. It acts against the movement of objects and can slow them down or stop them altogether. Now, talking about mass and momentum, mass measures an object's inertia, or its resistance to change. Momentum, on the other hand, gives us a measure of how much motion the object has, considering both its mass and velocity. Finally, all these concepts are interconnected: force, motion, inertia, momentum, and they form the foundation of understanding how objects behave when they move or interact. This wraps up our key points on the laws of motion and sets the stage for applying these principles in real-world situations. Now, moving on to the final slide, I want to highlight how we are committed to providing academic tutorial services across a wide range of student levels. We cater to primary classes, intermediate, and even senior secondary students, specifically those studying under the CBSE board, along with other relevant examination boards across India. Our approach is flexible, offering both offline and online modes to ensure accessibility and convenience for all learners. Whether it's in-person coaching or virtual classes, we aim to elevate each student's learning journey. Remember, our goal is to make quality education accessible and engaging, no matter where the student is or what their preferred mode of learning might be. ClassCloud is about transforming education, making it more effective, personalized, and aligned with today's digital world. So, as we wrap up, I hope you see how our comprehensive services are designed to support students at every stage of their academic path, truly elevating their learning experience.